So the focus of today's podcast is to help you understand the way to express the concentration of solutions. And earlier this year we talked about parts per million, parts per billion, percent. Those are the types of units that you would see if you picked up a newspaper. But in chemistry, the way that we express concentration is a term called molarity. Now, no surprise, molarity has in the word mole. Okay, we use mole all the time in chemistry, so no surprise that molarity would be the unit that a chemist would choose. Keep in mind that all concentration units are a ratio. They're a ratio of the solute, for example, the salt or the sugar, that you put into a solution, that you put into the solvent, such as water. So concentration is always a calculated ratio. And so if you think about the word amount of solute and amount of solution, depending upon what area of science that you're in, you might want that expression to be in grams or in moles or in volume. In molarity, it's moles of solute per liter of solution. Moles of solute per liter of solution, you can see. Moles per liter. So let's go to another problem and ask the question, which solution is most concentrated? A, B, or C? This is not difficult here. Don't overthink it. Yeah, B is the most concentrated solution. The way that you would say that, you would say 12.0 molar HCl. Now, this is the HCl that you used earlier this week in lab when you were testing colloids and suspensions, and you had to wear gloves and goggles and extreme care in working with the concentrated hydrochloric acid. Next question, which solution is the most concentrated in terms of a lead impurity? This is a review. These are concepts that we learned early in the year, so I'm not going to take the time at this point in this podcast to go through it, because our focus in this chapter will primarily be on molarity. But do you have an answer? Here comes the next slide. Okay? Yes, 4% means that 4% of the mass of the solution is lead. 4 parts per million would be 4 grams of lead in 1,000,000 grams of solution. That's much smaller than a 4% solution. So we're going to do problems with molarity that uses the concentration expressed as moles of solute per liter of solution. Solute, solution, moles, liters. Those are details you want to keep track of. So in this problem, what we're going to do, the first problem, is to calculate the molarity of a solution given 0.8 moles of sodium hydroxide that are dissolved in enough water to make 250 milliliters of solution. You'll be doing this in a few days, doing some calculations and then getting ready for the next lab. So the solute is sodium hydroxide, the solvent is water, the volume of the solution that you need is 250 milliliters. So of course, since molarity is in moles per liter, we've got to convert, first off, milliliters to liters, and then we're going to plug that into the equation, the moles and the liters, to calculate the molarity. Did you do this? Stop for a minute. If you didn't get the answer, go back to the previous slide, rewind, and take a minute to think about this before you just listen and not work out. You should be doing these podcasts with a pen in hand and thinking it through, not going to the next slide until you have worked out the answer. Okay? We took the moles, we converted the milliliters to liters, moving the decimal point over 3 places, and solved it and found that we had a 3.2 molar solution of sodium hydroxide. So, second example of the problem. So now, in this case, we need to make 100 milliliters of a 1.5 molar solution of calcium nitrate. How many grams of calcium nitrate are needed? This is the most common problem that my lab assistants and I solve in preparing for your labs. When we need to make a solution for a lab, I have to figure out what volume do I need for the lab and what concentration of this solution do I need to prepare. So first I have to recognize that I have to calculate convert milliliters to liters, and then I also have to find the number of, first I have to find the moles before I can find the grams. Remember, if I know the volume and I know the concentration, then I can use the formula for molarity. Molarity equals what? Do you remember? Moles per liter. So if I know the molarity and I know the volume, I can calculate moles. Once I know moles, can I go to grams? Can you pause? See if you can solve this problem. It might take a few minutes, but pause and see if you can do it. Here comes the answer. First of all, we calculated the moles. We converted milliliters to liters. That goes in the denominator. X moles, that's what we're trying to find. Our molarity is this value. Now what do we have to do? We have to convert moles to grams. So what did I have to use? I had to use the molar mass. Where did I get the molar mass? I had to add up 1 calcium, 2 nitrogens, and 6 oxygens to get the molar mass. Remember, up here we have an equal sign. Down here, it's a times. Make sure you distinguish. Remember, if you see an X within the problem, it should be an equal sign. But if there's no X and you're just solving the problem, it's dimensional analysis, and that's a times sign. Third problem. Again, if you didn't get the last problem, go back, rewind, try the notes, try listening to the notes before you move on to this one. This is getting a little bit more complicated. Maybe you need to go back and read your book. So, this is the problem, 75 grams of aluminum chloride. What volume of a solution could I make? Okay, I'm running out of aluminum chloride. This is what I need. How much could I make? Do I have enough, or do I have to order it from the store? Okay, so our plan is, first of all, if we're given 75 grams of aluminum chloride, do I know the formula of aluminum chloride? If I know the formula and I have the grams, can I go to moles? Absolutely. Once I know moles and I know molarity, can you find the liters? Do you see the plan? Again, you've got grams, you need the formula first, then you got to go to moles using the molar mass, then you can plug the necessary information into the equation and calculate the answer. Stop. Do this. Don't look at the answer. Okay, now, how did you do? Hopefully you got the correct formula of aluminum chloride. Did you convert to the proper number of moles? 1.10 moles of aluminum chloride. Next, I'm going to plug the given 2.5 moles from the problem into the equation for molarity. I'm going to bring down my calculated moles of aluminum chloride, and I'm solving for X. Okay, now remember, if X is in the denominator, what do? Get it out of there. Get it out of there. Solve for X. Your answer should be 0.442 liters. That's 442 milliliters. Not a large volume. Okay, so here's your homework for tonight. Hopefully, if you had trouble with the problems, the podcast will help you. If you got stuck on a problem, go back. Review the podcast, do the problems. Don't just listen to the problems. That doesn't help you. Reread the textbook. Take notes on the textbook. Signing off. Hope you have a good night.